So in this lesson today, we're going to determine what kind of shape things are by using the diagonals. And if the diagonals have the same midpoint, then we're going to talk about what kind of shape it is, and we're going to talk about how the diagonals affect each of these shapes, okay? So our activating strategy today is that we're going to talk about always, sometimes, or never. What is the case here, okay? When are these always true? When are these sometimes true? When are these never true? Okay, so a rectangle is a parallelogram. This is always true. Why? Because opposite sides are parallel in a rectangle, right? Okay. A rhombus is a square. This is sometimes true. Why? Because a rhombus means it has four equal sides, right? But a square also has four right angles. That's an angle symbol, okay? Quadrilateral is a parallelogram. Well, this is sometimes true as well. What does a quadrilateral mean? A quadrilateral means it has four just sides, right? That's what a quadrilateral is, four quad, okay? Parallelogram means it has two pairs of parallel sides, okay? Those are the differences. All right, so this next thing is the midpoint formula. So to determine the coordinates of a midpoint, you can use the midpoint formula. Y'all should have seen this last year, but if not, we're going to cover it today. So we have 2 points, x1, y1, and x2, y2 on the coordinate plane. Then the midpoint of the line segment that joins these 2 points is the midpoint xm, ym. And so we're going to add the x values together and divide by 2. And then we're going to add the y values together and divide by 2, okay? So when we add them together and divide by 2, that means we're finding the average of the 2 points. All right, so what is the midpoint of segment AB? Okay, so what we're looking for is, we're going to label these x1, y1, x2, y2, and our formula for xm is going to be equal to x1 plus x2 divided by 2, and then our ym is going to be equal to y1 plus y2 divided by 2, okay? So we're just going to plug in these values. So that's -1 plus 3 divided by 2. So that's going to be 2 divided by 2. So this one is 1. Does everybody see that? Okay, now we're going to do the y values. So we're going to do our 5 minus 1. Remember, we add a negative, we're just subtracting. So that's going to be 5 minus 1, which is 4. And that's going to be divided by 2. And so that's going to be 2. So our point is going to be 1, comma 2. Okay? So now I'd like you to do this next one and then check it with a neighbor. Okay. Pause the video, come back to me. All right, so now x1, y1, x2, y2. So I'm not going to write the formula again because I have it above there. Okay, so we're going to go 2 plus 2 divided by 2. So that's going to be 4 divided by 2. So that's going to be 2. So that means my x value is 2, right? Then we're going to go -5 minus 3. Divide that by 2. That's going to be -8 divided by 2. That's going to be -4. So my midpoint is going to be 2, -4. Okay? All right. I need you guys to pause the video here, do the you do, and come back to me when you're done, and let's see if we can get this one right. Okay, here again, x1, y1, x2, y2. So you're going to go -5 minus 3, plus 3, divided by 2. So that's going to be -2 divided by 2. That's -1. So that's the x value of my midpoint. Now we're going to do our y's. -3 minus 3 divided by 2 is equal to -6 divided by 2. So that's going to be -3. So this is 1, -3. Oops, sorry, -1. I didn't put the negative there. I see it up there, but I didn't repeat it over here on the right, did I? Right here. It's there, but I had to bring it over to there. Be careful with that kind of stuff. Okay, so the next thing we're going to talk about are different shapes. So parallelogram, to prove a quadrilateral is a parallelogram, we show that its diagonals bisect each other using the midpoint formula. So what does that mean? That means that I take this point and find their midpoint, which would be there. And then I take this point down here and this point up there and find their midpoint, and the midpoint should be the same. Okay? Now, when we talk about rectangles, to prove that a rectangle is a rectangle, we show that its diagonals bisect each other again. Now, this is true of all of these shapes because they're all parallelograms, okay? So, the other thing that we would do is we would say that they are congruent, and we would use the distance formula for that. We're going to talk about that and do that in a minute. Okay, so here again, to prove a quadrilateral is a rhombus, we're going to show that its diagonals bisect each other. Same property again, right? Why? Because it's, again, a parallelogram. But we're also going to show that they're perpendicular, okay? And that means they have negative reciprocal slopes, right? So there's your slope formula. Now with the square, to prove a quadrilateral is a square, we're going to show that its diagonals bisect each other again. And again, we know squares are parallelograms, so, but we also know that the diagonals are congruent and perpendicular. So we're going to use the distance formula and the slope formula to prove that, okay? All right, so for this example 2, we're going to just look at the diagonals, okay? So I propose that I think that this, we're going to find the midpoint. We're going to find the midpoint of this very first one, and then we're not going to find the midpoint of any of the rest of them, okay? Because they're all going to be some type of parallelogram, okay? So here's our AC. So point A is 0, 10, right? And point C is -2, -1. So what we're going to do is we're going to find the midpoint of AC. And to do that, we're going to go 0 minus 2 divided by 2, comma, 10 minus 1 divided by 2. Those are our x, y values, right? So that's going to be -2 over 2, comma, 9 over 2, right? So that's going to give us, what? -1, 4.5. So that's the midpoint of AC, okay? Now we're going to find the midpoint of DB. Okay, so here again, D is -6, what is that, 7? And B is 4, 2. Okay, so what are we going to do? Add our x's together. -6 plus 4 divided by 2, comma. That's our x value, right? Then we're going to do our y value. 7 plus 2 divided by 2. Okay, so this is going to be -2 divided by 2. And this is going to be 9 divided by 2. Isn't that the same values we got a minute ago? It is. So it's going to be -1 and 4.5. So because these midpoints are the same, we can say this is a parallelogram, okay? So this is all this proves, is that this is a parallelogram, okay? Because the midpoints are the same. So now, what are we going to talk about? We're going to talk about the diagonals, okay? So I want to see if we can figure out how, if these diagonals are the same length, because I think, based on what I see, that this is probably a rectangle. So we're going to look at AC. We're going to find the length of it. So we're going to go rise over run. So we're going to count up. I always go from left to right. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 up. And 1, 2 over, okay? So to find the length of AC, we're going to do 11 squared plus 2 squared. That's going to be 121 plus 4, which is the square root of 125. And then we're going to compare that with the other diagonal, okay? So now we're going to look at DB right there, okay? We're going to look at DB. And you should be able to see that that's falling, right? So that's going to go down 1, 2, 3, 4, 5. So that's going to be -5 squared. Remember, it doesn't really matter that it's negative because when you square any number, it becomes positive, right? And then we're going to count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this was -5 over here, and this was 10 down here. So it's going to be plus 10 squared. So that's 25 plus 100. And guess what? Actually, I'll write it out just like I did the other one. Square root of 25 plus 100. So that is also the square root of 125, right? So we're going to say AC is equal to DB. And because AC is equal to DB, this is a rectangle. And that's all we had to have, y'all. to prove that this was a rectangle, right? Because if the diagonals are congruent, then it's a rectangle. All right, on this next one, we're going to prove that this is, looks to me, it's not a rectangle and it's not a rhombus, right? I mean, not a rectangle and a square. Sorry, not a rectangle and square because we don't have right angles, okay? But it might be a parallelogram. So how are we going to find that again? This time we are going to look at AC, right? So we're going to do x1, y1, x2, y2. Y'all see that? So for AC, we're going to find the midpoint of AC. So we're doing -7 plus 4 divided by 2, comma, 5 minus 2 divided by 2, okay? So what is that going to be? -7 plus 4, that's going to be 3 over 2. And this is going to be, isn't that, yeah, that's 3. And this is also going to be 3 over 2, right? Isn't that going to be 1.5? So this is 1.5 comma 1.5, isn't it? So 1.5, ooh, that's supposed to be a negative, isn't it, y'all? Negative. So this is a negative 1.5, okay? So we're going 1.5, 1.5. Right there's where we think it is, okay? So now let's do the other one. We're going to do now DB. So we just found, just so y'all know, we just found the midpoint of that, right? Didn't draw it very straight, but y'all get the drift, okay? And now we're going to find the midpoint of this one, okay? So once again, we're going to go x1, y1, x2, y2. So that's going to be for DB. We're going to go -9 plus 6 divided by 2. And we're going to go -2 plus 5 divided by 2. So -6 plus 2 is going to be, there's our -3 over 2 again. Look at that. And this is going to be 3 over 2 again. So we don't really have to take it to this point because we can see that these two right here are equal, right? So they do have the same midpoint. So this is a parallelogram. Okay? We knew it wasn't a rectangle. We didn't know it wasn't a rhombus. I'm pretty sure you can tell also that it's not a rhombus. Sorry. We knew it wasn't a rectangle or square because it's not got right angles. Okay? All right. So this next one looks to me like it could be a square. Okay. So let's look at AC. AC. So there's two properties if we think this is a square that should apply to these diagonals. They should be the same length and they should be perpendicular, okay? So let's just do rise over run right here first because that's going to also help us with our length of AC. So we're going to go 1, 2, 3, 4. So that's a -4 and over 1, 2, right? So the length of AC is, or well, let's just talk about the slope. We'll talk about the slope first. So that's going to be -4 over 2, which is going to be -2, right? Okay, now remember, if we're talking about the length of AC, we take those two numbers, our original numbers, -4, square it, plus the 2 and square it, and then we take the square root of that. So that's going to be 16 plus 4. So that's going to be square root of 20, right? Okay. So now we're going to look at DB. Okay, that one right there. Okay, so here again, we're going to compare the slope. So DB's slope is 1, 2 up, and 1, 2, 3, 4 over, right? So this was 2 up, 4 over, so that's equal to 1/2. So right now, we could already say that AC is perpendicular to DB. Y'all see those slopes right there? Okay? So now we're going to talk about the length of DB, okay? So if we're talking about the length of DB, aren't we going to take these two original numbers, okay? 2 squared plus 4 squared. So that's going to be, again, 4 plus 16. And that's also going to be the square root of 20. So what does that tell us? That tells us that these are also the same length. AC is equal to DB, right? So if the diagonals are perpendicular and equal, then this is a square. All right, So here's our last one. Definitely know it's not a rectangle. It's not a square, right? So we need to determine whether it's a parallelogram or if it's a rhombus. Okay, so this is the property we know. If it's a rhombus, the diagonals are perpendicular, right? So I'm going to look at JL, okay, and go down 1, 2, 3, down 3 over 1, 2, 3. So the slope of JL is equal to -3 over 3, which is -1, right? Okay. Then we're going to look at the slope of NK. NK right there, okay? So on this one, we're going up 1, 2, 3, 4, 5. So we went up 5. So we're talking about NK. Slope again. We went up 5, and we're going over 1, 2, 3, 4, 5. And that's +1, right? So remember, both of these are over 1, okay? So what really happened? They did flip, didn't they? Once there were negative reciprocals of each other, right? So if, and they changed the sign. One was positive, one was negative, right? Okay. So that means JL is perpendicular to NK. And that's all we really need to say this is a rhombus. And we know it's not a square because the sides are not perpendicular. Okay. That's it. Don't forget to do your delta math. It starts today and is due next Thursday.